Yeah.
Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining for this exciting webinar with Dr. Vasant Shastri. This is the second webinar of 2024 from our knowledge series 2024. And we will continue bringing you more exciting topics and more exciting speakers to this series of our knowledge, to this series. Welcome, Vasant Shastri, and thank you so much for being with us today. In spite, I know you have a very busy schedule, and I know we are lucky that today you're not teaching. I know that. So, with that, I will introduce Dr. Vasant Shastri. Dr. Vasant Shastri is not new to IIVM. He has been a regular speaker at IIVM conferences right from our first conference in Calcutta, where I first met him. So Dr. Vasant Shastri holds a PhD in yoga from S. Vyasa University, Bengaluru, India. His topic for PhD is Evaluation of Vedic Mathematics and Yogic Breathing Module in the Management of Mathematics, Anxiety, and Cognitive Skills in School Children. He completed his master's degree in mathematical sciences from Bangalore University in 2006. Currently, he's working as a Hatha Yoga teacher and a mathematics consultant. He has worked as a vice principal, HOD of mathematics, and JEE KCET coaching faculty at Sri Sai Angels Pre-University College, Chikamagaluru. He has worked as a research project fellow at Design and Technology Department, Homi Bhabha Center for Science Education, TIFR, Mumbai. He has worked as senior associate consultant at education company BrainStars, Bengaluru. And currently, as I was talking to him, is a faculty with an organization called Teacher, TCHR, correct? Am I pronouncing it correctly? TCHR. And with them, he is guiding the students preparing for their competitive exams for engineering and defense services. Correct me if I have said anything wrong, Dr. Vasant.
Perfect, you're right.
Perfect. With this, I request everybody again to follow the house rules of muting yourself so that we are in sync with what Dr. Vasant Shastri is going to teach us today. And the talk is for around 30 to 40 minutes. We will first listen to learn what he has to tell us today, and he will take the question answers after the presentation. So on to Dr. Vasant Shastri, and welcome Dr. Vasant again. Thank you.
Yeah. Check the audio. Is the audio clear? Hope the audio clear.
Yes.
Now I cannot hear you. I can just it has have made this one way. Yeah, fine. All right. So welcome to everyone for this magical world of graphs. So today's topic is magical graphs, and today what we are going to do is how to read the graph. This is what we are going to learn in today's session, and using the graphs and from the different perspective. If you do that, you can crack many of the competitive examinations, that is kind of engineering entrance exams, easily. So whole idea is to read and conclude about the graph of the function. So before getting into the function, I would like to begin with the basic building block of mathematics, which is set, right? So all of us must have learned set in high school, right? Your teacher must have asked you, what is set? Someone must have given an example, a collection of beautiful girls attending IIVM conference. Do you think it's a set? A collection of beautiful girls, is it a set? No. According to me, someone is beautiful. According to someone else, the second person is beautiful. So there is no well-defined structure. If I say the alphabets, English alphabets, in English alphabets, if I select vowels, A, E, I, O, U, if I say the vowels in the English alphabet, then everyone in this session will write this. It is well defined, not ill defined. Well defined collection of objects is called set. Correct? This is the first definition about the set. So based on this, we have built the entire mathematics, isn't it? Set of natural numbers, set of the integers, and 1, 2, 3, dot dot. It will go up to infinity, plus or minus 1, etc. Correct? So like this, we have built the entire discussion about algebra, right? Natural numbers, integers, real numbers. But if you take two different set, right? Let me take n, set of natural numbers, and integers. All right. So from the natural number set, for some reason, 1 is related to 2. All right. And what I do is, the set of integers, I will write 0, -1, -2, dot dot dot. From minus infinity to plus infinity, you list out all the numbers in the set of integers. Got it? For some reason, 1 is connected to +2, 2 is connected to +4. In this way, it goes on. All right? 2 is related to 4. Right? When we say some element in the first set is related to some other element in the second set, all right, we call that as relation. When we say it's a relation, if it is a part of the Cartesian product. What is Cartesian product? See, Cartesian product n cross z can be written as 1 cross 0. I should write the ordered pairs, 1 comma 0, well, 1 comma 0, 1 comma 1, 1 comma 2, so 1 comma infinity, all the digits. Similarly, 2 comma 0, like this you write all the pairs, all possible connection, all the pairs. That is Cartesian product. Subset of this Cartesian product is called relation. Any subset, right? So that is the definition of relation. Hope everyone understood this part, right? So these are all basics that we learned in the high school mathematics. Set and relation. When you take two sets and for some reason the numbers are related, in this case 3 is related to 6, etc. So you can in fact redefine this and write it algebraically. This relation R can be, or R1 can be defined as x comma y such that y is equal to 2x, something like this. Right? But this is from n to z. So if I change this and write real number to real number, you call that as a real valued function. Real valued function. Got it? So today's discussion is restricted to all real functions. Right? We don't take complex numbers. So when we write real numbers, we get all decimal digits also, 1.1, 1.2, 1.3. So this is a rough example about a relation. So this is how we have learned about relation. Now the rule that we discovered, we can call that as a function. When let me tell you about the difference, the distinction between the relation and function. The difference between the relation and function, right? How do you find that the difference? It's very simple. Graphically, if I draw the graph of the function like this, within second or within 2 seconds, you can say whether it is a relation or not using vertical line test. Let me write two different relations now. The first relation goes like this: R1. The ordered pair is x comma y is equal to 2x. Y is equal to 2x, and the relation R1 is from real number to real number. Got it? So this is how it is defined. And second relation, once again, R2 is from real number to real number, and R2 is defined as y square is equal to x, something like this, right? Or change these two. Y square is equal to x over here, and y is equal to 2x over here. Got it? So y square equal to x is a parabola. Hope you guys know this, right? If you draw the curve, if you draw the graph of the parabola, or y square equal to x, it looks like this, turning right side. And you hold the pen in front of the graph. You hold the pen, you do it along with me. You hold the pen in front of the graph, right? And there will be vertical line. The pen shows you the vertical line, correct? If the vertical line cuts the curve at two different points, you can conclude that this is not a function. It's a relation. What is function? Function is a special case of relation where only the, see, I'll give you an example. 1, 2, 3, right? And A, B, C. If 1 is related to A or B, 2 to A, 3 to C, you can call this as a function. Whereas in the second case, 1 to A, 1 to B, 1 to C related, this one is not a function, right? So because the ordered pair 1 comma A, 1 comma B, 1 comma C is sitting inside the relation, such kind of relation is not a function, right? So it doesn't have a unique image. One has got so many images, right? But in this case, every element sitting in the first set has got unique images. Only such relations are considered as function. So first we learned set, second we learned relation, third, every relation is not a function, but every function is a relation. It's something like this: every square is a rectangle, but every rectangle is not a square. The discussion exactly sits with this, right? Every function is it's a special case, right? But we don't have to bother much about all these algebra if we know how to draw the graph. You just draw the graph of that relation and you know how to draw the graph. You assign certain values for x and y. Put x equal to 0, y 0, mark the point. Put x equal to 1, right? You get the value of 1. Or put y value, put y equal to 1, x is also 1, 1 comma 1. Like that, you can mark different points on the graph and join them, you get this kind of curve. So once you know the curve, you hold the pen in front of the graph and you will come to know vertical line test fails. So this is not a function, but y equal to 2x is a straight line passing through the origin. How do you draw the graph? You know, drawing the graph is simple. Put x equal to 0, y is 0, mark that point. Take 2 or 3 different points. Put x equal to 1, y is 2. So 1 comma 2, some other point, you join those 2 points and extend. It will be a straight line, correct? But in this case, if you hold the pen in front of the curve, interestingly, it cuts the curve exactly at one point. At any place, you move the pen from left to right, you move the vertical line from left to right, you will come to know that the pen, rather the vertical line, cuts the curve only at one point. So you can conclude that this relation is a function. So this is, the first magical conclusion. Just by looking at the graph, you can decide whether it is function or not. But this is a beginning of today's journey. Now let us go through the graphs of different functions. All right. From the graph, we can conclude about differentiability, continuity, right? Whether the function is odd or even, is it one or many one, onto or into, so many different things we can discuss, right? So here I draw some of the familiar functions, right? So if you already know the nature of the curve, it'll be good, right? So the function y is equal to x is a straight line passing through the origin. Y is equal to x square is a parabola like this. And I have already told you the trick of drawing the graph. Just assign 2 or 3 values for x and y. Put x equal to 0, y is 0. Put x equal to 1 square, y is 1 comma 1. So 1 comma 1 will be there somewhere here, isn't it? So you mark those points. Put x equal to -1, right? -1 square is 1. So -1 comma 1 will be somewhere here. You join those 2 points, you get this curve. So it is ideal to know these basic curves, right? Before attending any of the competitive examination, or to understand mathematics better, these graphs saves time and helps us a lot. Let's see. Y is equal to x cube is the next function. It goes like this. Got it? Yeah. So y equal to root x. Y is equal to root x is a function, right? 0 to infinity is the domain. 0 to infinity is the codomain. All right. So there are different kind of functions, right? Maybe split function, like absolute value function, greatest integer function, right? All these are well defined, and we have learned about these functions probably in the high school mathematics. Now here is a beautiful list. Why I'm discussing all this? Why I'm discussing all this? Just to know whether the given function is one or not, onto or not. Is it continuous? Is it differentiable? Even, odd? Is it periodic? To know about the function, all right, I should draw the graph, and within 10 to 15 seconds, just by reading the graph, you can tell about all this, right? So function, algebraically, what do you say about the function? When the element in the first set has got unique image, you consider that as a function. This is the definition of the function. It should have a unique image. Number 2, one-to-one function. When do you call the function as a one-to-one function? This kind of relation should be there. One-to-one. One-to-one. All right. See, I will give you one more example. 1, 2, 3, A, B, C. 1 is related to B. 2 is related to B, 3 is related to C, 1 to many. You take this as many one function. All right. So that's how the discussion goes. This is not one, but many one. This one is one. Similarly, onto function. When the codomain and the range are equal, you call that function as an onto function. All right. So 1, 2, 3. Maybe 2, 5, 6, 7. For some reason, these digits are related. All right. This function is not onto. The reason is codomain is this entire set. All right. Set B is a codomain, but these are the related elements 5, 6, 7, which is a range. Range 5, 6, 7 is not equal to the codomain. They are not equal. They are different. That is why this function is into function. Got it? So this is into, not onto. But if all the elements are related, I will add one more element over here, 4, and now you see the range and codomain both are same. In such case, you call that as onto function. So these are all definitions. Before approaching the graph, I'm explaining the definitions. Continuous. When do you say the function is continuous? When there is no break in the graph, right? Or algebraically. That's a very simple way of looking at the continuity, but algebraically you say left hand limit of the function as extends to a minus is equal to limit of the function as extends to a plus is equal to f of a. You write all this novel, isn't it? Mathematically, algebraically, we test this condition to know whether the function is continuous at that point or not. But now in today's session, by looking at the graph, we can conclude. That is the challenge, right? Next is differentiability, right? In the graph, if there is sharp edge, you can conclude that function is not differentiable. But technically, algebraically, what do you do? In fact, you find left hand derivative and right hand derivative. If both are equal at that point, you conclude that the function is differentiable. So much laborious work, but that is how we mathematicians go, right? But when do you say the function is even or odd? When f of minus x is equal to f of x, we say the function is even function. And when it is periodic, f of x plus k, some constant, will come into picture, right? If this is equal to f of x, that means after a certain point, the value of y repeats, right? So in such case, you call that k as period, time period, the function is periodic. Otherwise, function is not periodic. So this is all about the definition. Now, quickly, let us get into the word of graphs. So we begin with modulus function or absolute value function. I will show you drawing the graph of this function and looking at this graph from different perspective so that I can conclude about these things. Is it a function? I can answer. Is it 1, yeah, onto, yes or no? All that I can say just by looking at the graph. That's the power of the magical graph. So f of x is equal to modulus x or absolute value of x. Hope you understood. Absolute value function, right? So how do you define absolute value function? It is defined in this way. For positive values of x, y or f of x is plus x. When x is equal to 0, when x is 0, the value of the function is 0, and when x is less than 0, the value of the function is minus x. Why? See, when x is negative, we are focusing on the absolute value of the function. So that means y cannot be negative. To make it positive, I should write minus x. Negative into negative, it will become positive. So that's how this function is defined. Now you give some positive value. When x is 0, y is 0, right? You can initially, I will show you drawing the graph of the function, right? At the later stage, we can quickly draw the graph, but initially let us write the entire table. X, y, let us assign certain value for x, right? So x is equal to 0, y value 0, mark the point on the graph. All right, so similarly, when x is 1, positive value, y is also 1. So 1 comma 1 somewhere here, 2 comma 2, isn't it? So minus 1, if I take minus 1, minus of minus, it becomes plus. Yeah, negative value. So when x is minus 1, y is plus 1. So the point is somewhere here. Similarly, minus 2, when x is minus 2, y is plus 2. So if you join those points, the graph looks like this, right? So this is how, the minute you look at the graph, I mean the function, right? The definition of the function, you can draw the graph. This is the way of drawing the graphs. You will get some rough idea about the nature of the curve, right? Once this curve is in front of you, you can easily decode several things. So the number one, first question, is it a function? I'm first of all in a doubt. Is it a function? So you take out your pen, hold the pen in front of the graph, right? If you are high school students or K11 students, if you are in a doubt, you're in the initial stage of learning calculus, you may be in doubt, right? So you just hold the pen in front of the graph and you realize that vertical line test, this function passes the vertical line test. That means this is definitely a function. And is it 1, 1? For that, what you should do, you hold the pen in this way, horizontal line test. Hold the pen horizontally in front of the graph. All right. Then what happens? From 0 to infinity, just move the pen in front of the graph and you realize that the pen or the horizontal line cuts the curve at two different points, meaning the function is many 1. That's it. It is not 1, 1, it is many 1. All right. So it is ideal to memorize some of the standard graphs to crack these defense and the competitive examinations. But even if you don't know, you can simply, assigning certain value, you can simply draw the graph like this, right? So once you have drawn the graph, the rest is very simple. It is not 1, 1. Is it onto the codomain and the range should be equal? Then the function will be onto. You read the graph now. You read the graph. The y value starts from 0. The graph, the curve, doesn't exist below x-axis, isn't it? Yeah. So that means the curve starts from 0 and goes up to infinity, meaning the range of the function is 0 to infinity. The range of the function, including 0, goes up to infinity, which is not equal to codomain. Codomain is real number because this function is defined from real number to real number. The second set is a codomain, correct? And the codomain and the range that we have got is not equal. So you can say function is into function. It is not onto. You understood? So this is the way of reading the graph, continuous or not. Is it continuous? You just look at the graph. Is there any break? No, there is no break in the graph, so it is continuous. Is it differentiable? There are smooth edges, but except one point. You look at this point. At x is equal to 0, there is a sharp edge. There is a sharp edge at this point, meaning there may be two tangents, more than one tangent at that point. So the conclusion is function is not differentiable at x equal to 0. At all other points it is differentiable. Is it periodic? If there is a pattern, repetitive pattern, if that exists, you say the function is periodic. If the repetitive pattern is not there, you say it's not periodic, non-periodic function. For example, sine function is, right? Sine function is a periodic function because there is a repetitive pattern, right? Absolute value function is not periodic, right? Now, let us quickly understand the transformation of graphs. While attending these entrance examinations, which decides your career, right? You may be looking for in Navy examination, Air Force, or Army examination, or engineering entrance examination or science related examinations, in all those examinations, usually composite functions or like this kind of functions, these things will appear, right? So if you know the transformation of graphs within 10 seconds or 15 seconds, you construct a graph and conclude about this data. So here is mod x plus 2. If plus 2 is added, then the graph looks like this. You just have to shift the entire graph 2 units above the x-axis. Originally, mod x was like this. All right. So entire system shifts. The absolute value function shifts 2 units above x-axis if plus 2 is there. Correct? Is it a function? Now you check. Rest of the things you just check. Hold the pen, it's a function. Is it 1, 1? Hold the pen, it is not 1, 1. Is it on 2? No, it is not on 2 because 2 to infinity is the range. Correct? And real number is the codomain. Is it continuous? Yes. Is it differentiable? At one point not differentiable, that is x equal to 0. Correct? At x equal to 0, function is not differentiable, right? So periodic, no. So like this, you can quickly conclude about all those things. Next is mod x minus 2. What if negative 2 is there next to absolute value function? The entire graph shifts 2 unit below x-axis in this case. And again, you can read the graph. Is it a function? Hold the pen. Yes, it's a function. Is it 1, 1? Hold the pen. It is not. It is many one function. On to no. Minus 2 to infinity is the range which is not equal to codomain. So it is into function, not on 2. Continuous, yes. Differentiable at x equal to 0, not differentiable. You see the magic of the graph. You can take out so many data from the graph. Not only this, there'll be much more to this graph, but in this session I'm just taking the calculus part. So modulus of x minus 2. What if the negative 2 exists inside the absolute function? Then the entire system shifts right side of y-axis, so it looks like this, 2 units. So quickly you can draw the graph like this, right? And you decide about the rest of the things. And the next, modulus of x plus 2. If positive 2 is sitting inside the absolute value function, then the entire graph shifts 2 units left side of the y-axis. So the graph looks like this. This is applicable for all other functions, right? This rule is applicable for any function, right? The next is, minus mod x. If the negative sign is there, right, next to absolute value function, then the whole graph looks down. That is the beauty of the graph, right? So it looks like this. If you know the nature of these graphs, it becomes very easy to conclude about 1, 1, many one, and differentiability, right? And the next is 3 times mod x. If some constant is there along with absolute value function, then the graph shrinks. The original graph may look like this, but this graph would shrink. The nature of the function is similar to modulus of x. All right. So what about mod x divided by 3? Absolute function divided by 3, then it expands. The nature of the graph is like this. And this is applicable to all other functions, like y equal to root x or anything else, right? So the next is sin x. Now I will show you the composite functions. Sin x graph originally looks like this. Am I right? So it sits between -1 and +1. Sin x graph, right? Here it is pi by 2, pi, 2 pi, etc. Right? So this is the graph of sin x. Sin 3x. See, some constant is there next to x. Sin 3x. In this case, it should shrink. Nature of the graph. right? You see, it goes like this. You can compare this graph with the original sin x, right? If there is x by 3 sitting in front of sine, then the curve looks like this. You see, it expands. This is the nature of the graph. And how about modulus of sin x? Originally, sin x goes like this. Modulus of sin x is a special case, and you should know how to draw the graph quickly. Modulus of sin x, you get only the positive value, isn't it? If there is absolute value of sin x, if you are taking only the absolute value of sin x, that means the value would be positive, meaning you just have to flip the curve about x-axis. You should take the image of the curve about x-axis. That means, these regions below x-axis won't be there. So the entire curve now looks like this. Got it? That's the beauty of modulus of sin x. And how about sin mod x? If you put absolute value function only to that x, cos mod x, sin mod x, tan mod x, e power mod x, for all those functions, this rule is applicable. So what you do when there is modulus to x, you just draw the graph of the curve on the right side of the y-axis. You just consider only this part of the curve. Don't draw the curve next to the y-axis, left side, right? But you take the image about y-axis. You take the image about y-axis, then the curve looks like this. It's something like this. Someone is looking at the mirror. Y-axis is a mirror, and you are standing over here and you are looking into the mirror like this. Got it? Then obviously the image looks like this, isn't it? Yeah. So if you raise your right hand, the image will be a left hand, isn't it? So the graph also looks like that, and sin mod x goes like this. With this, you can say several things about the graph. You see, at this point, at x equal to 0, function is not differentiable. Isn't it? Because I can see sharp edge. Originally, at x equal to 0, function is differentiable. The minute I write sin mod x, at x equal to 0, function is not differentiable. There is only one point where the function is not differentiable. But modulus of sin x, function is not differentiable at infinitely many points. Look at this. We get so many sharp edges, isn't it? So with this, let me quickly show you some of the questions from the entrance examinations. So here is a question. I will take some 4 or 5 questions from the entrance examinations. 18th April 2024, just 2 days back, in the engineering entrance examination, this question arrived. Modulus of cos x, everywhere continuous and differentiable. Everywhere continuous but not differentiable at odd multiples of pi by 2. These are the options, right? So now you guys know how to draw modulus of cos x. Cos x graph goes like this. It starts from +1, isn't it? +1, isn't it? Yeah. Cos 0 is +1. Cos 90 is 0, right? So this is cos x graph, but modulus of cos x, you should take the image about x-axis, then modulus of cos x goes like this, isn't it? So by looking at the graph, immediately you conclude there are so many points at which the function is not differentiable. So everywhere continuous but not differentiable at odd multiples of pi by 2, because pi by 2, 3 pi by 2, and there'll be 5 pi by 2. These are, the consecutive points where the function is not differentiable. So option B is the correct answer. Hardly we have taken 10 seconds. So that is the beauty of the graph. You should know to read the graph, right? And the next is JEE examination, right? These are all Indian entrance examination for the engineering course. So JEE is considered as one of the toughest, and nationwide students prepare for this examination over here at the K-12 level. And the mod x minus 1 by mod x plus 1, what do you do? Not a standard curve, right? Let us follow this procedure. Yeah, so first what we do, we just assign certain values for x and find y. So when x is 0, y is also 0. Oh, sorry, not 0, I think it is minus 1, isn't it? 0 minus 1, 0 plus 1, so I get minus 1. Minus 1 is here, so 0 comma minus 1 is a point in the graph, right, in the Cartesian plane. So 0 comma minus 1 I mark, and the next is plus 1. If I assign plus 1 to x, then y becomes 0. 1 minus 1, 0. So when x is 1, y is 0. This is point. This is a point, I think 1 comma 0. And this one is, I believe, 0 comma minus 1. So 0 comma minus 1. Similarly, you can take negative value, or you can assign negative value to x. Modulus of minus 1 becomes plus 1. 1 minus 1, 0. So when x is minus 1, y is 0, isn't it? So the curve looks like this. Something like this, right? But this is not the end of the graph. Wait a minute, right? You assign two more values, or at least one value, to conclude about the graph, that is something like 10 or 100, right? The number larger than this digit is ideal. So 10 or 100. So put 10 over here. 10 minus 1 is 9. 10 plus 1 is 11. 9 by 11. But it's common sense. You assign any value for x, denominator will be always greater than the numerator. Yes, denominator will be always greater than the numerator, and always there'll be difference of 2 between these two digits. That means the number is closer to 0.9, 0.9, right? So 0.9 is somewhere here. So for all other values of x, the y value goes up to 0.9, so the curve looks like this. The minute you know the nature of the curve, you can answer this question that they are asking whether it is 1, 1 or not. That's easy. You hold the pen in front of the graph. So you came to know the curve, the pen, the horizontal line cuts the curve at two different points, so it is many one. And how about onto or into? From minus 1 to plus 1, right? Including minus 1, excluding plus 1, the curve exists. That means this is the range of the function, which is not equal to codomain, which is the second set, meaning it is into, not onto. So neither 1, 1 nor onto is the correct answer, right? I think I have exceeded the time, so I will take one more question. So like this, there'll be many questions connected to 1, 1 and onto. You can answer that kind of questions. 2017 JEE exam, you can follow the same method. Less than x square. Again, they are asking about continuity, differentiability, and all. Modulus of f of x. So the curve exists only above x-axis, isn't it? Y equal to x square, or f of x equal to x square, is a standard graph. Looks like this. But if you put modulus, there won't be any part of the curve existing below x-axis. Correct? So less than or equal to x square. That shows that the function, or there'll be several functions which sits between y equal to x square and this x-axis, isn't it? But if you look at this graph, easily you can say the function is continuous. It is continuous everywhere, and it is also differentiable. There is no sharp edge, right? So it is continuous and differentiable. Differentiable, not continuous, right? That is deleted continuous and differentiable, option B should be the correct answer. So like this, you can quickly answer these questions, but there are so many, but I will take one from the derivative. 2019 CET examination, function is x minus box x minus cos x, right? The question is, what is f dash pi by 2? Then find the derivative, and at x equal to pi by 2, what will be the value? Yes, yeah. So you differentiate this function, you differentiate the function, differentiation of x is 1. The derivative of x is 1. Am I right? And how about the derivative of greatest integer function? Box x is a greatest integer function. And if you know the graph of the function, greatest integer function, you say the derivative of box x is 0. We are looking, we are finding the derivative at pi by 2, right? F dash of pi by 2, pi is 3.142, so approximately 3 by 2, that is 1.5, 0, 1, 2, 3, somewhere here, 1.5 is somewhere here. At this point, you observe the graph or read the graph, you read the graph. At this point, the curve is parallel to x-axis, and if you draw the tangent at that point, the tangent will be parallel to x-axis. Slope of the tangent is 0. Slope is nothing but derivative. Yeah, that means at this point pi by 2, the derivative of greatest integer function is 0. You just read the graph. So 1 minus 1, you differentiate cos x, right? Cos x, you get minus sin x, right? So 1 minus 1, yeah, so you get minus sin x over here. So 1 minus 1, 0, minus of minus plus, at pi by 2, sine 90 will be 1, right? So this is how you can answer this kind of questions connected to calculus, right? Or 0 to 8 box x. In this case, we are integrating, because 0 to 8 box x dx is area under the curve. Box x is the greatest integer function, not greater than x. What will be the value of 0 to 8 box x dx? How do you go? Do you have any idea of integration of box x? Right? It's in fact very easy if you know the graph. You draw the graph, 0 to 1, 1 to 2, 2 to 3, 3 to 4, right? You see the magic. 4 to 5, 5 to 6, 6 to 7, and 7 to 8. The graph goes on like this, but you drop the perpendicular from all those points, you get rectangles. Yes or no? You get rectangles. And the integration of box x is nothing but area under the curve. Area under the curve, that means you find the area of the rectangles, you will get the answers. Area of this rectangle is 1, 1 into 1, 2 into 1, area is 2, 3 into 1, area is 3, 4 into 1, so 4, 5, 6, 7. You add the areas of all these rectangles, you will get 0 to 8 box x dx, isn't it? So that is 1 plus 2 plus dot dot dot, it will go up to 7. That is summation 7, isn't it? 7 into 7 plus 1 divided by 2, n into n plus 1 by 2. 7 plus 1 is 8, 8 by 2 is 4, 4 into 7, 28. So 28 is there in the option. Option 1 is the correct answer. So this is how the graph works magically while attending the engineering entrance examinations, right? So that was all about the magic of graphs. We have several other questions to discuss, but I would like to answer your queries, so we can discuss now. Over to Swatiji.
Thank you, Dr. Vasant. This was great, and I do have, if there are any questions directly, you can unmute yourself and ask, or if you have a question, you can put it in the chat. I can ask Dr. Vasant, whatever works for you.
Check.
We do have a few comments. Let me just check for the comments. IVM, that's James, you saying? Who's saying? No, Ramya is saying, awesome, you've taught us how to think. And Ravya Sraniji says that very useful for aspirants of competitive exams. Thank you for the excellent presentation.
Okay.
And there's one
I have
message.
a comment.
Yeah, go ahead, James.
Oh, sorry. What's that? Excellent. Really, really good. A lot of these aspects, particularly the transformations, seem to come under the Sutra Paravartya Yojayate. Would you agree? Because they're all like transpositions of one sort or another. So it was just, nice to, I think it's nice to relate it to Vedic maths as well. But very good.
In Vedic mathematics, there is one sutra, isn't it? Mere observation. So
yes,
it's actually a holistic approach. It is not just you cut down everything and you look at the pieces of the question. We don't do that. In Vedic maths, basically what we do, we go with the holistic approach, and this in fact exactly sits with that sutra, mere observation. In fact, we are looking at the graph from the different perspectives, but it's a holistic approach.
Yes. And also when you hold the pen up vertically and you hold the pen crosswise, I don't think we need it's vertically and crosswise.
Yes. True. Yeah, any questions?
Are there any specific questions of something that was taught, you didn't understand, want him to explain again? But all said and done, we have recorded the session. It will be available for everybody who attended the session. And again, if you have any questions after or during watching it again, do reach out to us. And with this, I hand it over to Raghavendra to give his closing remarks.
Yeah.
I think Dr. Vasant, the explanation was perfect. Nobody has any questions. Either they understood everything or they're going to watch it slowly and then understand everything. Let's go with that.
All right.
Yeah. Go ahead, Raghavendra.
Yeah, thank you, ma'am. Thank you very much. And Dr. Vasant Shastri, it was very nice presentation, and we enjoyed. So you started from your title is magical graphs. So there is a magic in that, and you have found out, and you have explored, and also given us the taste of what is the magics behind these graphs. He has started with the basics of what is sets, relations, Cartesian products, and also what are real functions. Then how do we identify, like how graphs are very, very helpful in finding out the difference between what is a relation and also a function, and how graphs are very, very helpful in finding a function related to differentiability, continuity, even, periodic, and all. This is very, very helpful in calculus, as well as that too for great entrance examination like CET and IIT. He is an expert in that field, and he different kinds of functions, and he brought us to the what is the world of graphs by looking at the graph, and also by drawing the graph of it, how we can easily identify whether it is a function, whether it is one, whether it is onto, continuous, differentiable, and periodic, just by observing, and also if any changes are there in the values like mod x plus 2 or mod x within that, and all, sin x, sin 3x, and all, how easily we can identify. And he has taken 3 examples of entrance examination, or 2 more examples he has taken in how to identify, and within 10 to 15 seconds how we are able to find out whether which is the right answer. and really you have taken us into a very great what is called as path of graph. How the graph are very, very helpful in understanding what are the characteristics of a function. We can easily understand, and it reminded me of my second PUC as well as my teaching, as well as I'm happy, like, once again, if I'm able to take up a entrance examination, maybe some 3 months of training would be very, very helpful, so that I can crack IIT JEE. Really, it was wonderful, sir. And you are close to, like, as Swati madam has told, from 2016 only you are associated, and also we want some more inputs from your side, how we can connect Vedic maths and all. You have explained during the 2016 conference also. If some more such solutions are there, we can bring back, integrate, and also we can help the students as well as faculty members who are teaching maths and also Vedic mathematics put together, so that how it can make the world very easy and also interesting for us. Really great. Thankful for your great explanation, and also we all became students of you, and your explanation was very, very, and even if I blink, I may lose something. It was the speed and also a great insight you have given it to that. Really, thank you very much for spending your time and also giving the cream of this knowledge of what is called as graph. Thank you, Vasant Shastri, sir. It's very nice of you, and have a nice weekend. And any queries are there, we can write to us also. Thank you, ma'am. I will hand over to Swati, ma'am.
Thank you. Thank you. Someone is asking my Gmail ID. So here I write VASANTH VSHASTRI@gmail.com.
Yep.
Right.
Yeah, perfect. Thank you so much again. And for everyone who were joining this knowledge series for the first time, or being introduced to what IIVM does for the first time, for whatever reason that would it be, like Dr. Vasant Shastri pulled you into this webinar, just take a look at our website. We do conduct this knowledge series webinar regularly. We also have our annual online conference coming up in the month of July. We will put out the call for papers very soon. We will have our annual International Vedic Mathematics Olympiad in the end of November. So please stay connected. We have you on our mailing list. But to know more about IIVM, please like our Facebook page, subscribe to the YouTube channel. We have tons of resources on our YouTube channel. And as usual, please connect with us if you have any further queries on Vedic mathematics or any of what we do. And thank you, Dr. Vasant, again. And I'm sure this is not the end of our connection for this year. We're going to keep you inviting for many other things. Thank you so much.
Yeah. Uttara, that is the correct email ID. Someone is asking.
Yeah, Vasant Shastri@gmail. Is this correct?